Okay, so let's try to study this problem, longest increasing subsequence. The problem say that given an integer array nums, return the length of the longest strictly increasing subsequence. Okay, so if you have any doubt about subsequence, you can follow my another lecture on subsequence subarray subset. Okay, and the examples are given as 10, 9, 2, 5, 3, 7, 1, 0, 1. So this is the one example and this is another example, or three examples has been given. Okay, and we need to find the longest increasing subsequence. So if you start from 2, okay, so 2, 3, then 7, then 1, 0, 1. I mean 2, 3, 7, 18 also can be a increasing subsequence LIS, but we need to just return the length of the longest. So which is over here it's 4. Okay, so before jumping to this problem, so let's try to understand. Okay, so let's take an example, 1, 3, 5, 1, 7. Okay, so let's say this is one array has been given. So let's find out the LIS at ending at 1. Okay, so this is 0, 1, 2, 3, 4. So LIS ending at 1. So LIS ending at 1 is just 1. Okay, and length is 1. Okay, LIS ending at 3. Okay, so better let's say ending at 0. Let's say we'll maintain index over here. So LIS index at 1. Index at 1, what is the longest increasing subsequence? So it is 1 and 3, right? And length is 2. Okay, now LIS ending at 2. So 1, 3, 5. So length is 3, right? LIS ending at 1. Sorry, ending at 3. Okay, so here 1 is lesser than 5, right? So we cannot make a subsequence with 1. So in that case, it will be only one element, okay, in the subsequence, and the length is 1. Okay, LIS ending at 7. Okay, so sorry, LIS ending at 4. Okay, so what is the longest? So 1 and 7. Okay, length 2. But wait, so this length, this is LIS ending at 4. Is this correct? No, right? Because we can make a subsequence with 1, 3, 5, 7, right? Which is the length 4. But over here, if we count longest, so we'll get 3 as the longest. Okay, which is incorrect. Okay, so in this case, so we have previously calculated the longest increasing subsequence till at index 2 is 3. Okay, and at index 4, if we check the previously calculated LIS, then we can make a decision, right? Then we can make a decision to make 1, 3, 5, 7, right? So in this case, we can say like we are checking, first of all, it is asking for maximum of something, because you have to find out the longest increasing subsequence, so maximum of something. Okay, second thing, we need to make a decision from previously made decision. So which algorithm we can apply? I think we can apply dynamic programming. This is a suitable candidate for dynamic programming problem actually. So in this case, so what we'll do, okay, so first we'll because we need to store the length, right, so at each index. So let's declare a dp list of size 4, or array we can say 0 1 2 3 4, okay, 0 1 2 3 4, and each element, each number is LIS. Each number can be a subsequence and it can be a longest. Okay, so in that case I can initialize with 1. Okay, now let's fill up the things over here, whatever we have calculated. So 1 2 3 1 2. Okay, 1 2 1 2 3 1 2. Okay, but problem is over here. Okay, and we need to depend on this value. Okay, this index value. So here the number was what? Number was 13517, right? So 13517. Okay, now how to calculate dp of 4? So dp of 4 we can write as dp of 2 plus 1, right? So dp of 2 is 3 and plus 1, which is 4. But is this correct? It can be there can be a scenario which is this can be 4, right? So this can be 4, which will, or let's say this is 5. Okay, let's say so in that case this value will be ignored, right? So in that case we can say better we should calculate the existing cell value as well, the existing ascent value as well. So we can say, so in that case we can say maximum of dp of 4 comma dp of 2 plus 1, right? So in this case we are considering the current cell value as well as the previously calculated decision as well over here. Okay, so if we say this is j, okay, and this is I, so you can say dp of I is equal to maximum of dp of I comma dp of j plus 1. Okay, so this we can run a loop from 0 to till end of the till the length of the nums array, and another loop will run till I. Okay, so you can say, so let's say n is the length of the nums array. Okay, so in that case we can say for I in range n. Okay, for I in range n, and for j in range I. Okay, so if nums of I over here 7 is greater than 5, right? So 7 is greater than 5, so nums of I is greater than nums of j. Okay, so in that case we can say dp of I. Okay, we'll put this over here, dp of I is equal to maximum of dp of I comma dp of j plus 1. Okay, I think we are good. And finally we can say return, we need to return the max over here. So here it will be 4. Okay, and 1 2 3 1 4, what will be the max? 4. So you can say return maximum of dp, so it will get 4, and 4 is the answer. Okay, now what will be the time complexity for this? We are running 2 loops. Okay, so in this case the time complexity would be O of n square. Space complexity, you are maintaining a dp list, okay, of size n, so in this case it will be O of n. Okay, but is this the better solution? Can we not optimize? I think we can. Okay, so let's discuss the better approach. So in this case, what we'll do, we'll intelligently build the subsequence. Okay, so we'll build the subsequence by noting that whether an element is what to take or not. Okay, so if it is what to take, if it helps to make the LIS, okay, so then it is what to take, otherwise it is useless, right? Okay, useless fellow. Okay, so in this case, so let's say we'll take one example, 7 to 5, 3, 4, 9, 5 and 12. Okay, so we'll make one dabba. Okay, we'll subsequence. Okay, in this dabba, in this subsequence, we'll put 7 as default. This is the default value. Okay, default guy, no check, nothing, it will come as usual. Okay, now what we'll do, so next we'll check 2. So 2 is less than 7. Okay, so in this case it will be in the dabba. What we'll do, 2 is less than 7, next element. So what we'll do in the dabba, in the subsequence array, or like the array we are the dabba we are maintaining, so there we will replace with 2. If it is lesser, it is 2. So first is 7, only one element is there, it's useless, right? So we'll replace it. Okay, done. So in this case 2 is less than 7, so replace 7, length 1. Okay, next we'll get this dabba, we have 2, now 5 is incoming. Okay, so 2 comma 5 we can put, because 5 is greater than 2, no replace, so it is append we are doing, length is currently 2. Okay, and initially length was 1 only, I mean you can maintain. Okay, and then we got what, 3. So 3 is lesser than 5, 3 is less than 5. So as soon as we got less than 5, so what we'll do, we'll find the smallest element which is just greater than or equal to 3. Okay, so which is just greater than or equal to 3 is 5, so we'll replace with 3. Okay, replace 5, length is 2. Okay, next we got 4. Now 4 is greater than 3, so it will be append only. So 4 is greater than 3, append, action will be append, length we got as 3. Okay, next again we got a very suitable case, suitable candidate. Okay, 2, 3, 4, 9. Okay, 9 is greater than 4, so it will be append only. No, what you are looking for, length is 4. Okay, next there is a problem. Okay, 5 we got, 5 is less than 9, which is the last element over here, right? So 5 is less than 9, so in this case 2, 3, 5, smallest element. So smallest element, which is the smallest element over here, which is just greater than 5. Okay, which is just greater than 5, so 9 is the smallest element which is just greater than 5. So 2, 3, 4, 5. Okay, so here replace 9, length we got as 4. Okay, next we have 12. Okay, we have got a suitable candidate. Okay, very nice candidate. 2, 3, 4, 5, 12. 12 is greater than 5, so we have appended. Okay, append action is append, length we got 5, and this is the largest length so far we have found, and this is the LIS we can say. Okay, So we can see over here, so there we had two operations, either we are appending or either we are replacing. Okay, so there are two cases is one. So if the num is greater than, greater than num is the incoming, whatever we are iterating over here. So if the num is greater than the last element in the dabba or the sub array or the array or the list, last element in the and dabba I'll not write in the list. So if the num is greater than the last element in the list, so action is append. Okay, next, if the num, another case we are doing replace, right? So if the num is the lesser than the last element in the dabba in the list, so we are doing replace. And while doing replace, we are considering one condition. So we are finding the smallest element which is just greater than the incoming element or incoming element or num. We are iterating over here, right, as num incoming element. Okay, so finding the smallest element which is just greater or equal to, I made a mistake, greater than or equal to the incoming element. And this portion in binary search we call as lower bound. Okay, so I'll make the playlist of binary search. I will let you know, but as of now you can just remember, like in Python we have a one-liner syntax, lower bound, bisect left. So if you do bisect left, right, so in that case we will get the lower bound. Okay, so we have everything in place. Okay, so we have the dabba, okay, with the default element. So and we have the logic also in place. Okay, so let's put the logic over here. So let's take a dabba subs list. Okay, inside that we'll initialize with the nums of 0 default element. Okay, when you don't have anyone you can assign, right? So yeah, so nums of 0. Okay, and then we'll iterate. Okay, so for num in nums, if num is good candidate, okay, num is greater than last element subs of -1. Okay, if the last element, then we can say like subs dot append num. Else that is a problematic element. In that case we need to find the lower bound index. Okay, so we can say k is equal to bisect left. So in this method, in this inbuilt function in Python, we can pass the subs array, dabba, and num, which is the target. Okay, so if we pass that, then it will give you the index, so which is the smallest element which is just greater than or equal to the current num. Okay, so in that case we can get the index, and what we will do, we are doing replacing over here, right? So replace is operation. Okay, so in that case we can say subs of k is equal to the current num. Okay, and finally, so this will build up the entire dabba or the array. Okay, and finally we can return the length of the subs array. So over here it was, we found as 5, right? So it will return 5. Okay, so now what is the time complexity for this? So time complexity for this bisect left, this we take help of binary search. So in for that, the time complexity would be log n. This we are iterating all the elements in the array, so it will be O of n. So what will be effective time complexity? Effective time complexity would be n log n. Okay, and space complexity we are maintaining is a dabba, right? A list. So in that case, it can, in the worst case, it can go, it can contain all the elements. Okay. So I mean, if the case is 3, 4, 5, right? So 1, 2, 3, 4, 5. If this is the nums array has been given, then the entire array will be in the dabba, right? Okay.